Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMathInstruction. Today, we're going to be doing Unit 6, Lesson number 3 on factoring trinomials. Now, in the last lesson, we reviewed two types of factoring. That was how to factor out a greatest common factor, and also how to factor the difference of perfect squares. Today, we're going to tackle arguably the hardest type of factoring, which is factoring trinomials. All right? So let's jump right into that. Now, before we factor trinomials, what we're going to be doing is we're going to write we're going to get a little practice on, I don't want to call it the opposite of factoring, but sort of the opposite process, which is multiplying, right? Multiplying binomials. So it says, without using your calculator, write each of the following products in simplest ax squared plus bx plus c form. Now, technically speaking, the way that one of these products is done is by what I would call double distribution. In other words, I'm going to multiply 3x by 5x plus 7, and I'm going to add 2 times 5x plus 7. So in other words, both of these quantities distribute into here, or better yet, this distributes to both of those quantities. Then, distributing again, giving me 15x squared plus 21x plus 10x plus 14. Now notice we've got four terms here, and before we move on, let's talk about those a little bit. Where did the 15x squared come from? That came specifically, let me go in red, the 15x squared specifically came from multiplying 3x by 5x. Now that's very important. On the other hand, the 14 specifically came from multiplying the 2 and the 7. These other two terms, which eventually just get combined into a 31x, they come from the fact that I've multiplied 2 by 5x to give me 10x, and 3x by 7 to get me 21x, right? Now our final answer of 15x squared plus 31x plus 14 isn't all that remarkable and isn't all that important. The important thing to understand, and let's talk about this as we go on to letter B, is that really we have these first two terms which multiply together, gives me 4x squared. These last two terms that multiply together, they give me negative 15. But then we have an inner set of terms which gives me negative 6x, and an outer set of terms which gives me positive 10x, which then will always combine. Right? Nothing combines with that 4x squared, nothing combines with that negative 15. But these two always combine and give us that sort of center term. All right? Many times students use what's known as a FOIL process to multiply binomials. First, outer, inner, last. All right? Any way that you do it, why don't you pause the video now and take care of C and D. All right, let's go through them. So in letter C, whoops, gotta use the right side of the pen, right? We're gonna get 5x times x, 5x squared. I'll get negative 4 times x, negative 4x, 5x times negative 2, negative 10x, and then negative 4 times negative 2 would be a positive 8. Again, nothing combines with these two terms, but these two terms, in this case, combine to be a negative 14x plus 8. Remember, at that point, you're just combining like terms. Finally, let's do this one. 4x times 3x is 12x squared. 3 times 3x is a positive 9x. 4 times negative 8 is a negative 32x. And 3 times negative 8 is negative 24. Again, these two combine to give us a net negative 23x, and then minus 24. Now, when we factor, what we're going to be looking to do is start with all the things that are circled and go backwards to these products, and that is much, much harder. But we're going to learn methods to do it in this lesson and then even more in the next lesson. So pause the video now and write down anything you have to before we start to factor. Okay, let's clear it and let's start to factor. Okay, so I want to take this trinomial and break it up as the product of two binomials. Okay? And I've given 4 guesses here because basically, let's just cut right to the chase. In my opinion, there's only one real way to factor trinomials. Guess and check. If your teacher shows you another way that works with products and sums and magical boxes and things that just disappear, hey, fair enough, right? That's up to a teacher's discretion. But to me, the best way to factor a trinomial is to guess and check. So let's start working on that. All right. Below are 4 guesses of how this trinomial factors. 2 of these guesses are unintelligent, meaning they should not even be checked. Cross them out and explain below them why they are unreasonable. Think about this for a second. All right, let's talk about them. Well, I claim that this is an unreasonable guess. And the reason it's unreasonable is that x times x is x squared, but I need 6x squared. So that one's out. I don't have to check anything else. Nothing's going to combine with an x squared to give me a 6x squared. We kept trying to emphasize that in the last problem. I also claim that this one makes no sense. Now, granted, 3x times 2x is 6x squared, but negative 2 times negative 3, that would give me a positive 6, but I've got to have a negative 6. A negative 6. So that one's out. All right, these 2 are both reasonable guesses, and let's again talk about that for a second. These are reasonable because 3x times 2x is 6x squared, and 2 times negative 3 is negative 6. So the first term matches, and the last term matches. Likewise, 6x times x is 6x squared, and 1 times negative 6 is negative 6. So again, that's a reasonable guess. But one of them's correct and one of them's not correct, all based on this negative 35. And it's this simple, right? It's this simple to figure out which one is correct. We already know the first term works, and we already know the last term works. So all I need to do is check whether this product plus this product sums to be this. And the answer on this one is a resounding no. Let's check this one. 6x plus 1 times x minus 6, right? Here, again, I don't need to check the first and the last. I just have to see if this product, 1x, plus this product, negative 36x, gives me the right answer. Negative 35x, yes. So when I talk about guessing and checking, a lot of students say, I don't want to guess and check, because then I got to FOIL the whole thing out. I have to multiply these 2 binomials all the way out. But you don't. If you make intelligent guesses, i.e., you make guesses where the first terms multiplied give you the first term of the trinomial, and the last terms multiplied give you the last term, then all you have to do is sort of check the inner and the outer terms and see if they sum to be that second term of the trinomial. Whew. Lots of words flying around. Pause the video now and write this down. This is very, very important. Okay, let's clear out the text and start to factor some trinomials. It's all guess and check. All right, and we're going to start easy, then we're going to get a little bit harder and a little bit harder. Now, this first set of 4 trinomials is definitely the easiest, and also very, very important. But they're the easiest because the leading coefficients are all 1, okay? And that makes my life a lot easier because immediately I know this has to be an x and this has to be an x. Now the issue is, of course, looking at this 35. Now we know that 35 is 7 times 5 and 1 times 35. So these are both, reasonable guesses. 7, 5, and now what I need positives and negatives. Well, let me make an incorrect guess first. This is an incorrect guess, but it's a reasonable guess because x times x is x squared and negative 7 times positive 5 is negative 35. It's not the correct guess because when I multiply these 2 together and I multiply these 2 together and add them, I get negative 2x, but I'm supposed to get a positive 2x. So that's the wrong guess, right? It's just wrong. We can put a giant red line through it. Wow, even extended right there. That's weird. Anyway, so then I'll try this guess. X times 7, x minus 5. Here I'll get a positive 7x. Here I'll get a negative 5x, and when I combine them, I get a positive 2x, and that's what I needed. Let me circle this one in green, right? But that's it. That's the whole deal. Nothing more than that. And again, a lot of students don't like this because it requires throwing down a guess, checking it, and if it doesn't work, doing it again. But to not like that and to find little gimmicky ways around it with products and sums and things like that, well, I apologize if this seems a little bit harsh, but, well, then you don't like problem solving, right? I mean, because that's what it is. Problem solving is all about taking chances, seeing if they're right, and if they're not, going back and taking another shot at it. That's just the way it is. So, for instance, letter B, right? I see x squared plus 11x plus 24, and my first sort of instinct is, 24, 4 and 6, right? But the problem is plus 4x plus 6x gives me 10x. No, I need 11x. Maybe x plus 3 times x plus 8. Let's see, 3x, 8x, add them together, we get 11x. That's what I needed. Again, let me circle in green so we know what the right answer is. That's it. All right, why don't you pause the video and try C and D. All right, let's do it. Now, you can certainly use and develop some number sense on here, which is helpful. So, for instance, right, based on the fact that this is a positive 22, the way this factors either has to look like this, or it has to look like this, because these two things multiplied have to give me a positive. So they either both have to be negative or both have to be positive. But this is negative, right? Therefore, if we're going to start off with a guess that has a reasonable shot of being correct, we start with that. And then we see negative 11x, negative 2x, those combine to be negative 13x. That checks, and that means this is the correct factorization. All right, this guy. Again, you can also develop some good sense of things, right? 5 and 10, 2 and 25, etc. Probably 5 and 10. We know one's got to be negative and one's got to be positive because this is negative. And we can also develop a sense that the larger one has to be the negative because they have to combine to be a net negative. And this one does end up being correct. I'm not going to go through the check. Hopefully you got that one right. Now again, these were easy because I didn't have to think very much about the coefficients on the x terms because they had to both be 1. The next level is going to get a little bit harder. So don't fall into some really easy patterns and go, oh yeah, man, I got this factoring trinomial business down. All right, pause the video and think about what we've done, and then let's clear it out. Okay. Exercise 3. Using a guess and check technique, factor each of the following trinomials that have prime leading coefficients. Show each check, guess, and check. Now, I think of these as being sort of the second easiest or the second hardest, depending on how you want to look at it. And what I mean by that is ones where the leading coefficient on x squared are both prime numbers. Okay? Now, the reason that I think that these are still fairly easy is that, again, I have no choice. It's got to be 3x and x. It just has to be. All right? But having a coefficient there other than 1 now starts to throw things off a little bit. Okay? Now let's talk about 40. It's got to be negative, right? But what do we have? We got 2 and 20. We've got 4 and 10. We've got 5 and 8. All right. And I kind of do want to walk down the road of at least one wrong guess. So let me put like a 10 here, and let me put a 4 here, and let's go negative and positive. One's got to be negative, one's got to be positive. So this is a reasonable guess again, because 3x times x is 3x squared, and 10 times negative 4 is negative 40. So it's reasonable. It's not right, because when I multiply these two together, I get 10x. When I multiply these two together, I get negative 12x, and combined, those will be negative 2x. So, nope, that's not right. So let's try another one. Now, it could be the 10 and the 4, but maybe they're just switched. Maybe the 4 goes with the 3, and the 10 goes with the x. All right, but I'm gonna go with a 5 and an 8. I'm gonna go 5 here. I'm gonna go 8 here. One's got to be positive, one's got to be negative. And again, it's reasonable. 3x times x is 3x squared. Negative 5 times positive 8 is negative 40. Let's see if it's right. Here I'll get negative 5x. Here I'll get positive 24x. And when I add those together, I get a net positive 19x. And that's exactly what I needed. All right. The key is to try it as many times as you need to until you get it right. How about you pause the video now and you try this one? All right. Now, in certain ways, this problem's a bit easier, and let me explain why. All right. It's not about 2 versus 3. That's pretty irrelevant. But it's about the fact that this is a positive product, but a negative sum. And that means both of these things have to be negative. Now, here's where, of course, it's tough, because 18 is 2 times 9. 1 times 18, 3 times 6, and that's it. But what goes with what, right? Maybe it's this. Right? Again, reasonable. 2x times x is 2x squared. Negative 2 times negative 9 is positive 18. Let's see. I'm going to get negative 2x there, negative 18x there, and those two combined, with addition to be negative 20x, I need negative 15x. So no. But I do know that they're both negative. So let's try 3 and 6. Get rid of that, get rid of that, get rid of that. Let's see, here I'd have negative 3x. Now remember, it's 2 times negative 6, so that's going to be negative 12x. And when I add negative 3x, negative 12x, I get negative 15x, and that's what I needed. I mean, again, I could make hundreds of incorrect guesses and just keep checking. But we won't do too much of that simply because we're trying to get you the idea, not bang our heads in the wall guessing and then failing. All right. So pause the video, write down anything you need to, and then we'll factor some more. Okay. Let's clear it out and move it on. All right. Now, the absolute hardest problems, absolute hardest trinomials to factor, are ones where the leading coefficient are not prime. Not prime. So that's tough. That can be very difficult. Because first off, that 15 could be 1 and 15. It could be 3 and 5, right? This is much more difficult. Now, what should you start with? I don't know. Why don't we start with x and 15x? See how that works. Luckily for us, the 2's not too bad, right? I don't know. Maybe put the 2 here and the 1 here. Now, they both have to be positive because we have a positive product and a positive sum. So they can't be negative. So maybe that's it. What will we get here? Let's see, 15x, 2x. Remember, we're adding these. We get 17x. We need 13x. All right, so that's not right. We could flip-flop these, but we wouldn't find anything there either. So let's try 3x plus 2, and 5x, I guess it would have to be plus 1. Again, it's a reasonable guess. 3x times 5x is 15x squared. 2 times 1 is 2. So here we'll have 10x. Here we'll have 13x.
Oh my gosh, no way!
When I add them together, I get 13x. That checks. All right, pause the video and take a shot at letter B. One thing I like about factoring problems is you should know whether you have them right or wrong. So 10, well, 10, go back to blue. 10 is either 1 times 10 or 5 times 2. Well, let's go with 10x and x. Let me give me 10x squared. Ooh, 30. 30 is tough because 30 is a lot of different things. It's 1 times 30. It's 2 times 15. It's 3 times 10. It's 5 times 6. And that's it. Oh, man. Ooh, I don't know. Let's just take a shot. Let's go with this. One's got to be negative. One's got to be positive. Why not? So let's see. We have 5x minus 60x. Gives me negative 55x. No. Right, I need a positive 13x, so that doesn't even come close. Let's try 5x and 2x. Let's go with a 6 and a 5. Let's see if this works. Negative 12x, positive 25x. Add those together. We have a positive 13x. We got it. Again, I apologize for not showing more incorrect guesses, but we'll see a technique tomorrow that will allow us to, well, in the next lesson, sorry about that, we'll see a technique that will allow us to make even better guesses, eliminate even more possibilities so that we're closer to the correct one. Pause the video now, write this down, and then we'll try 2 more. Okay, let me clear that out. All right, well, last 2. So I'd like you to pause the video, work on both of those, and then we'll go through them. All right, let's tackle them. Now again, if these were frustrating for you, I get it, especially with the 36. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. I mean, there's a lot of them for 36, right? So again, we could go about doing many guesses and many checks. Ultimately speaking, the correct guess and check on this one is 6x, 2x, minus 5, and positive 3. And again, let's talk about reasonableness. 6x and 2x, 12x squared, negative 5, positive 3, negative 15. But again, here's the kicker. There I'll get a negative 10x. Here I'll get a positive 18x. And when I add them together, I get a positive 8x. So that's got to be correct. This one, which probably would be the one that would take the most guesses, has 9x, 4x, 2, and 3. This is negative 8x, negative 27x. When you combine the 2, you get negative 35x. So it checks. Right. I know these can be frustrating. They can sometimes require a lot of guessing and checking. But if you understand how to make an intelligent guess, then the check really should be quite quick. All right. Well, pause the video now. We're going to clear out the text and finish up. Okay, here we go. We're going to need to be able to factor fluently throughout the course. And factoring trinomials is a critical piece of that fluency. All it takes is hard work and perseverance. Every one of us has that inside of us, not just for factoring trinomials, but for every problem that we tackle, both in math and in life. The question is, how long can we keep pulling on that perseverance before we give up? Don't give up when you're factoring trinomials. You will get them. Extra sheets of paper, that helps too. All right? So thank you for joining me for another Common Core Algebra 2 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.